Hey guys, welcome back. It's been ages since we last gave a contest. I hope we are not clumsy this time because we have been improving. We have done binary searches, sliding window, and all that shit. So I hope we'll be able to solve 3 questions quickly this time. And the thing is, I'll be using CPOS extension. So that will be a quick way. Okay, I need to open just in case. To debug, I'll need to do it in VS browser only, VS Code. Yeah, updated. Sure. My hair is a mess. Okay, 6 problems. A bigram is a string, is a pair of adjacent letter. For example, string hello contains 8 bigrams. HEEL. Okay, pair of characters is a pair of adjacent characters. Okay. Monocarp has cards with letters. C1 cards as letter A, C2 cards as letter B, and kth letter. Okay. So using each card exactly once, he wants to make the string from these cards. Using the card exactly once, the resulting string must contain at least 2 bigrams. The order of characters in each bigram matters. For example, the string ABA does not have 2 equal bigrams. Determine whether it is possible to make a string that satisfies the following requirement. Okay. Where is the editor? Is there an editor? Where is the editor? I can't see the editor option. Okay, I'll use it here. I need to read the question again. A bigram is a string. A bigram in a string is a pair of adjacent characters. So it has cards from letters C1, which is A, to CK, which is letter K in Latin. He wants to make a string from these characters. Using each card exactly once, can we make the string? He wants to make the string from these cards. The resulting string must contain at least 2 equal bigrams. The resulting string must contain at least 2 equal bigrams. So a pair of characters should repeat. A pair should repeat. The order of these characters in each bigram matters. For example, the string does not have 2 equal bigrams. Determine whether it is possible. So we take an input, then we where Ci is the number of cards with the ith letter. Okay, so we need two cards of each. Okay, editor is here. So let's start. Next. Okay, that was just some small thing I had to do. Okay, we'll take the test cases while t tends to 0. Should increase the font a bit. Test cases, and then each test case contains 2 lines. The first line contains an integer k, the number of cards, and the second line contains an array of k, and let's say c equals new int of size k, and for each k I plus plus, for each will taking the number of cards, which is c of I. C of I equals to sc dot next int. Okay, and let's say count, I'll introduce int o equals to 0. Then if o is okay, this editor is cool, but my webcam is getting, can I reduce the size of this webcam? I don't think I can I move this? Okay, let it be. So if c of I is greater than 1, which is 2, we need to do plus plus o, and if this o is greater than 1, then we need to print yes. Okay, I can't work here. I need to work on you restart the extension. Yeah, so if this o is greater than 1, then we need to print yes, else no. Why is there a no problem linked? Yeah, this should not be public. Reach the end of the file. Huh? This arrow is this is this. Yeah, what, why is it not working? I need to read the question again. In the first example, you can make a string a which contains no bigrams. In the second example, you can make a string a which contains 2 bigrams. So either there should be a pair of 2 different letters or same letter. Okay, let's say this is o, then another count int p equals to 0, and if c at I is greater than 2, I'll do plus plus p, right? Or p is greater than 0, not greater than 0, the number of, yeah, two elements should have more than 1, or one element should have more than 2. Okay, save this and submit. Okay, next question. I need to move quickly. source, we need to make this public. Okay, last time I said that I will be switching to C++, but I wasn't able to quite get the hand. I wasn't, what can I say, I wasn't able to learn that language that efficiently in this past few days, so I didn't switch it. Predominant frequency division. You are given an array consisting of numbers from 1 to 3. Check whether it is possible to split it into 3 contiguous non-empty parts such that for each part I from 1 to 3 the following condition holds. Into 3 contiguous non-empty parts such that for each part I from 1 to 3. Okay, for each part the number of elements greater than I is at most half of the part. In other words, you need to divide the array into 3 pairwise distinct contiguous non-empty parts so that in the left part the number of ones is at least the total number of 2's and 3's. In the middle part the total number of 1's and 2's is at least the number of 3's. The number of elements greater than I is at most half of the part. More than half should be number greater than I, and in the right part can be anything, but it must be non-empty. So what it is saying that a array A, we need to divide it into 3 parts so that part 1, 2 and 3, these are the names. Part 1 should have more than half elements greater than the number of ones should be less than the size, half of the size, so that number of 2's and 3's, the number of greater elements than I is more. That is what the question says, that the number of elements greater than I is the number of elements greater than I is at most half of the part. Okay, it is at most, not at least. Half of the part, it should not be greater than that. These numbers should not be greater, so this is at most half of the size, so this should be at least half of the size. The number of ones here should be at least half. The number of 2 here, the number of ones and 2's should be at least half. So the number of 3 is at most half. So the condition here is for 1, which is it should be at least half of the size of this array, and these are contiguous. And then the second array should have the number of 3's at most half of the size. For each test, okay, 2 1 1 2 3. Okay, so in the first case the number of ones should be at least half of the size. So if we take, so we reached here. Okay, I'll copy this. For example, the array can be split into 2 1 1 3 3. I'll copy this and work on this. Yeah, this is the array. So let's say we divide it into such segments that this is one of the segments, this is another, and this is another. So what happens in this size is 4, 3 and 1, and in this we need at least 2 ones. Yeah, this is satisfied. In this we need at most, what is half of the size? 3 by 2 is 1. The number greater than 2 should be at most half of the size. The numbers greater than I should be at most half of the part. So the 50%, in this part only 50%. The number of 3's can only be 1, it cannot be 2. And the last element can be anything, should be non-zero. So let's say we are going from right here, we are going from left here, we need 2 pointers and 2 pointers, and what we need to print out, yes if there exists a way, or else no. Okay, so yes if there exists a way and no if there is not. There are 3 segments. Let's say green is the first segment, blue and orange. The size are, let's say, P, Q and R. These are the sizes of the array. The total size is P plus Q plus R, and there are 1, 2, 3 elements only. The number of elements greater than 1 should be at most half of the size. So the numbers greater than 1, which is the number of 2's, 3's, should be at most, should be less than equal to P by 2. Which means if this is true, then the number of 1's is less than equal to P by 2, so the number of 1's is greater than equal to P by 2. In this case the number of, this is 2, so number of 3's should be less than equal to Q by 2, and this can be anything, but it should be non-empty, right? It should be non-empty. So we'll traverse through the array. So we come here and we count the number of 1's present here, and we count the number of size. We'll go till we find the first thing that happens. So let's say we come across 1. We come across 1. We'll traverse to the array, and first we need to satisfy this condition. So we'll go on increasing the size of the array, and we'll go on increasing this, and once this statement becomes true, we'll break it. So and we then start increasing q, and then once we start increasing q, we'll note down this. Okay, I got a small hint. Okay, but I don't know if this might work or not. Yeah, this was accepted. Where's the editor? I can't find the editor. Okay, I need to stop the timers. I didn't. Okay, let it be. We'll do it later. So this is the question. We'll copy this itself. So class main will take the integer, then we'll take n, then we need an array a which is of size n, till size is less than n I plus plus a of I equals to this. Let's say counter of 1 equals to 0, comma counter of 3 equals to 0, then int p equals to 0 comma q is also equals to 0. So we'll go through the array. We'll set a flag, boolean flag 1 equals to false, boolean flag 2 equals to false, and in this if flag 1, that means the first condition is not satisfied, we need to check for the first condition. Okay, if a of I is equal to 1, then we increase the counter 1. And also we need to increase the size of the array, and in this case if C1 is greater than equal to p by 2, then we need flag 1 equals to true. Flag 1 will be set to true. Again, if flag 1 if flag 1 is true, then we'll check for the next condition, that if int I is equal to 3, then plus c3 and plus q, we need to increase the size, and if this size is less than equal to q divided by 2, then we need to set flag 2 is equal to true. Now if flag 1 and flag 2 and I is less than n, okay, for the it should happen at n minus 2. So if I is less than n minus 1, then break. And we come out of this loop, and once we come out, we check if flag 3 yes, no, okay, is it flag 1 should be satisfied, flag 2 should be satisfied, and finally it should happen at Yes, no, yes. Yes, no, yes. Okay, 132. In the case of 132, what happens? 132. 1332, sorry. 1332. So our pointer is here. The number of ones. So C1 is equal to 1, P equals to 1. So is C1 greater than equal to P by 2? Yes, it is true. So we set flag 1 as true and continue. Okay, and we need to do continue. For the next iteration, we don't need to check anything else. So we need to continue. And in this case also, if it is true, we need to flag set here and also continue. And break, yeah. Everything is coming no. Let's say the last third case, which is 1 2 3. It should print yes, but it is getting no. So in case of 1 2 3, what happens? Can we divide it such that, let's say this is the division. In here, number of ones is greater than equal to 1 by 2. Yeah, it is correct. Number of threes should be less than equal to 1 by 2. Yeah, it is correct. In the last segment, yeah, it is possible, but why is it not working in my code? Why is it printing no? It should print yes. So we need to debug it. 1 2 3, right? One and 1 2 3. Okay, debugging is fun. So the first thing we check it, counter is 1. Yep. So is this true? C1 equals to 0. How is C1 equals to 0? If A at I, if A at 0 is equal to 1. Yeah, it is 1. Why is this not working? C1 was 0, and after executing it, was false. Now flag 1 is true. Then what happened? Why did we directly go to? If flag 1 is true and not flag 1 is true and flag 2 is false, it should execute. What does continue do? We need to move to the next iteration. So instead of continue, let's say I put plus plus I. Plus plus I. Let's say I put one test case which is 1 2 3, and I continue it till the end. Okay, does this work? Okay, what the hell is happening? Once I check this and a flag is set to true, I need to move to the next iteration, and that is done by continue. Yes, then why did it not work? Is C1 greater than equal to P by 2? It is. Continue should move to the next iteration. Yes. I equals to I was 0. So we need to execute this, right? N. What is N? Okay, 11132. My bad. No, the test cases is this 13132. Okay. I was putting in the note. Then the number of text cases, and then 1 2 3. What the hell? Okay. One, 3 and 1 2 3. It should print. Yes, it is possible. Then it prints no. I need to debug this case. Okay, n is equals to 3 this time. So C1 is 1, then P1 is true. The next iteration, then yeah, this goes inside. A of I is equal to 3 plus plus count of 3 plus plus count of q, and if it is less than equal to q by 2, then we need to move ahead. Yeah, it is true. So if 2 is equal to 2, continue. And now this does not get executed. This, if flag 1 is true, flag 2 is true, and the current I is less than n minus 1, it should be less than equal to n minus 1, then flag 3 is also true. Okay, what happened? In current I, so it was printing no. Okay, now if we do less than equal to n minus 1, what happens? Yes. Okay, this case, which all cases gives? I need to read another question. Let's read the third question because okay, I am spending a lot of time on VS Code. That is the wrong thing. I should be. You are given a sorted array. You can perform any number of operations on the following array. Mark the first element of the array as well as all the elements that are not equal to their left neighbors. That means a of I is not equal to a of I minus 1. So we'll mark that a of I. Then either delete all marked elements or duplicate them. That is, replace each marked element with two identical elements. So in this case, consider the array. Marked elements are shown in bold. Elements that are not equal to their left neighbors. Okay, this is not equal to left neighbor. This element is not equal to the left neighbor. This element is not equal to the left neighbor. Is equal to the left neighbor. So we need the first element of each different sequence. Yeah. So first element of each different sequence. Now if we delete all the mark element, we get this. And if we duplicate them, we get that. The operations cannot be performed if the array becomes empty. After each operation, every element gets unmarked again, and again it gets marked. So what does this? Okay, we call an array of integers B reachable if it can be obtained from array A by some number of the observed described operations. Your task is to count the number of operations reachable array of length k. In this first line, we take two integers n and k. Is it possible to reach? Your task is to count the number of reachable arrays of length k. It can be obtained from A by some number of operations. Your task is to count the number of reachable arrays. So the length should be same, and we need to find the number of different length of the array is k, and the number of reachable arrays, different arrays of length k from this array A, and this p should be different. So let's n and k in of length 5. How many different things of length 5 can we create? So only one. Let's say n is 4 and this is 5. The second line contains n integers. Yeah, so these are the 4 integers, and we have 5, and we need of length 5. We need of length 5. So we can either add, how many distinct elements are there? There are 2, so we can add 2 more. So it becomes or we can delete them. N and k. Okay, n can be greater than k, n can be smaller than k. N is this and k is this. So when n is this, what does deletion and duplication do? Number of distinct characters. Number of distinct characters. Let's say it is uh, D, not D, let's say it is letter P. There are P number of distinct characters present. When we delete them, it becomes n minus P, and when we duplicate them, then it becomes n plus P, the total size. And how is it possible that we can make 2 in test case? Fifth example, yeah, I need this. The arrays 1, 2 and 2 can be obtained. So we do 2 deletions. Okay, there is 3. Fifth example, we need of size 6. It is 8, we need of size 6, so we can do 1 deletion, it comes here, or we can do 2 deletions, or let's say 3 deletions and then 3 additions. A different array is formed when we delete a lot of numbers and then we add a lot of numbers. Okay, it should be non-empty. A string should be non-empty. So number of distinct characters, the number of what we need to print, the output is the number of distinct of size k. Is it possible? So this is 4, and to make it 4 we can duplicate it. That is one of the way. Then again, if we delete this each individual type, the number of distinct characters is 0, so it is not possible. Okay, so let's say initially there was P and we duplicate. Now still the number of duplicate distinct characters is still P, but once we delete the first P, the new distinct characters is something different. So the distinct character changes only when we delete things. Not when we duplicate it. So first, let's say this is our total number n, and then we do n minus p1. Okay, n minus p1, and which is not equal to k. Now it becomes n minus p2. Okay, because n minus p1 we do, so there are p2 different characters now. So n minus p1 plus p2 is not possible answer for k. So for each different answer, what we are doing is number of deletions and number of duplications. Let's say A amount and B amount of deletion and duplications. So let's say n, right? So when we do n minus p1 minus p2 minus p3, right? Initially there were p1 different characters. In n minus p1 there were p2 different characters. Then n minus p1 minus p2 there were p3 different characters. So finally it was n minus p1 minus p2 minus p3. There are p4 amount of different characters. So now this p4 we need to do that this plus some integer amount of p4 equals to k. That is what the answer is. we need a function for distinct characters. Okay, what are the constraints? The constraints are n and k raised to 3 to the power 5, and the array is sorted. We need to note that the array is sorted. Does that help sorting an array? I think it might help. So we'll just go until we find different characters, right? So if a of I is not equal to a of I minus 1, this is a distinct character. So we'll keep on adding it. We just need to compare this. So we need to compare the last element with something. So we'll create a function for number of distinct characters, and then we'll perform it till this is a very okay, I have understood the logic, I just need to implement it there. So will it be beneficial? So each time there are 3 to the 10 to the power 5. Do we need to create a hash map? Okay, we need a hash map. So the hash map, we take an array and it is not equal to k. The number of distinct character, we'll check the number of distinct character p4, is it a multiple of it? Is not, so we'll perform a deletion and then we'll check again. And we'll do these deletions till this is a non-empty set. This for each this set we find this, and then we check if it is k, and if it is, then we'll increment it. So what I mean to say is, while our set is not empty, our map is not empty, we do size of the map is size of the map plus minus k if this mod of distinct characters in our map is equals to 0, then we increase the counter. That is what we need to do. And how can we do this is we need to check the documentation for hash map. Hash maps. So we take an int, then we also take k. We create a hash map. Let's say hash map m of integers and integers. Integer comma integer equals new hash map, and k is there, then m dot put in the place of, let's say, x, right? In the place of x, m dot get or default x comma, what is the default value? 0. Whatever it is, plus 1. So that is a hash map created. Once we create a hash map, while the size of this hash map is not equal to 0, while, is there any function for size? What are the hash map things we can do? Set, okay, clear clone compute, if present, if contains key, contains value, entry set returns the set mappings contained in the map. For each get or default is empty. Returns true or false if the map contains no key value mappings. Map dot put key and value. Copies all the mappings. If the specified key is absent, remove the mapping. Remove the entry of a specific only if it is currently mapped to a specific value. Specific value. Replace all entries value with the result of invoking the given function on the intent entry will have been processed, or the function throws an exception. Number of key value, okay, till the size is positive. So while m dot size is positive, so if m dot size, let's say int s equals to m dot size, right? So while this size, if this s minus k mod the number of distinct key and value pairs, the total size, okay, the total size was n, while n is positive, let's say while n is positive, if the total number minus k mod this size is equal to 0, plus answer. And if this is okay, then it is true, and then we reduce the size of n. n equals to n minus s. Okay, this is the new size of the now we need to replace all the values by -1. We need to reduce. Replace result hash map syntax for decreasing each value by 1. To decrease each value in a replace key with value -1. Map dot replace key. Okay, for each key we need value -1, right? -1. Is a hash map immutable? Hash map, you must insert an immutable class. You can directly modify the value. You need to replace it by discarding the old value. Something like hash map was equals to new. Can we do an array list? Because there are 3 to the 10 to the power 5, right? We always will need, it'll get a TLE, I think. So we need to do this. Okay, so we need to remove that. So we'll remove that. Let's say for map dot entry of integer comma integer entry e such that m dot entry set. Okay, what was the syntax for iterating through the loop? For key set, for each key set, okay. M dot remove that key set. And we need to return the answer. $26. I need to debug this. This is not cheating, okay? I just am not familiar with the syntax because it's my first time. I'll just look over it. The loop is incorrect because you're modifying and removing iterating over the key set, which is can throw this exception. Iterate over a snapshot of keys, don't remove, just update the value. Use it iterate if you really need to remove. I don't need to remove. So integer key in key map in team pay equals to get that key. And if it is possible, we'll just put right. You need to remove this. 1. Okay, what is wrong? Okay, there is something small difference. So if the total size minus k is equal to map size, so that what is the map size? Map size is all the distinct values present. So let's look at this case. Let's say the first test case itself. In this case, 1, right? So 1 minus 5 is minus 4. Windows C, we need to debug this. Well, stop right here, let's see. N minus k is minus 4, minus 4 mod s is equal to 0, so it should. Okay, this did not work. N minus k mod size. If let's say the current size is less than k, then we need to check this. Yeah. If the current size is greater than k, else if, okay, now n is less than k, so we just need, okay, wait, now we just need to delete it. We just need to keep on deleting it. So after once delete, we need to do another delete, and then another delete, and then another delete. Okay, what is happening here? If k is greater than n, the total length plus some I amount of s equals to k, right? We are duplicating it. Here we are not duplicating it. Here we are removing the duplicates. We are eliminating it. We delete it and then we check if some multiple is correct. If we delete it and we check if some multiple is, we delete it and if check if some multiple is correct. So here, if some multiple of s is correct, while the size is positive. Let's say while m of size is okay, TLE. Concurrent modification exception. Okay, how much time have I given? 40 minutes. And how much time is left? We'll read the next question as well. Okay, 9,000 people have submitted it. We need to submit the second problem. We'll read this. We are given two strings A and B consisting only of digits. In one operation, you can choose two adjacent characters in either of these two strings and replace them with the sum modulo 10. For example, from 5726, you can obtain strings in one operation. You can obtain the following strings in one operation. So, which of 5, 7, 12 mod 2 is 2. 7, 2 is 9, 9 mod is then again 4, 2 is 6, then 4, 6 is 10, so 0. Note that after such an operation, the length of the string always decreases by exactly 1. Yeah, the modulo 10 gives a single answer. So yeah, you can perform any number of operations, even 0. You have to make these two strings equal. So A should be equal to B. For all okay, you need to make the strings equal, which is A y is equal, and each index should be calculate the maximum possible length of the resulting equal strings. So we are given two strings, so we need to come at a single thing. From the statement, the maximum length you can obtain is 2. The maximum length which is of same. This is a cool problem, but I don't think I'll have the time. Into contiguous non-empty parts such that part I from 1 to 3 conditions hold. The number of elements greater than I is at most half of the part. So what is the size? Number greater than should be at most 5. So in this case 1. The number of ones should be greater than equal to the half of the size. What is wrong here? Let's check the third test case, right? Answer should be last third, right? This one is last third, 1, 2, 3. So answer should be 1, 2, 3, yes. And I'm getting no. Yeah, it is wrong. So what happens? 1, okay, done. So 3 is the number greater than 2. Should be at most 1. It is no, that is no, that comes. No, how is it possible in this case? We take 1 and then we take 3 and then we take another 3. Should be greater than half of the size. Number of 1 should be greater and number of 3 should be less than half of the size. So in this case, it's greater and less. As long as this doesn't hurt, we can continue this, right? If flag 1 is true and flag 2 is false, start adding plus p. Greater than equal to, if c1 is less than, we'll start adding 1 again. So once this becomes less than equal to, that is where we break. So we start adding to the 2 and continue. Flag 2 is, we have set it right. If count of 3, so in the second part the count of 3 should be at most. If it is less than equal to q, then we need to set flag 3 equals to true and break. There is just a minor change here somewhere. I need to debug this. Let's start debugging. Yeah, let's go 13311. Okay, 13311. So I is equal to 0, we take 1, then we increase 1. Is this valid that count is 1 is greater than equal to, yeah, it is true. So set true and then the next loop. Then we again take 1 in the second loop. Yeah, c1 should be 2. If c1 we take 1. Okay, and continue. True. And now we move on to this. If c1 is equal to 1, we add it. If a at 1 1 3, okay, it is 3, so 3 and the p is 2. So is c1 less than p by 2? No, it is not. This breaks it. Is this correct? It does 1 3. 1 3 is a valid thing, right? If c1 p by 2, it is not, so it should accept it. Yeah, it accepted it. Then to the next move. 1 3 3 again, so p becomes 3. So is c1, now this is in danger, so we put this 3. Is c1 less than p by 2? P by 2 is, why didn't this get executed? If c1 is less than p by 2, so 3 by 2 is 1. How can we make this different? If p mod 2 is equals to 1, then limit equals to p plus 1, else limit equals to p. One and then 3. And then this is the next time we come to 3. So L equals to 4. Now it breaks. And if it was 3, the count is increased. Q is equal to 1. Now what happened? So if a at I is equal to 3 plus 3, so both of them are 3. So flag 2 is set to true. Okay. 1 3 and the third 3, this is where we break. Okay, break. 1 3 and break. And now the next 3. For the next 3, is this 3? Number of 3's is 1. is I, what is I is equal to 3, 0, 1, 2, 3, 1, okay, 1, 0, 1, 2, 3. This took a lot of fucking time. Yeah, still it is not working. Okay, let's look at the third problem. I was close to solving the third, right? I'm getting a logical error that at point 29 there is something. What is wrong here? Where's the editor? There is no editor. Okay, so we need to execute it here only. We need to debug it here only. What is this syntax? Windows 5. Your code is throwing because you're calling while iterating over this. Fix it by iterating over a snapshot or using iterator. If you don't actually need to remove, even simpler, no remove, so no exception. So don't use remove. If map has value as 0, does that key include in size? I think it will be included in size. Yes, in Java matrix count a number of key value mappings. The key with value 0 is still mapping, so it only keys actually removed with reduce the size. So we need to remove it, but some different way. So we don't need to remove it here. Temp key and temp p. And temp key equals to 0, and in temp v equals to 0. For each this, temp v is map of key, and temp key equals to, let's say, key, and we do this. And if it is positive, then we put 0, and if it is 0, then we remove that temp key. The last thing has an answer. Okay, we need to debug this. So 1 3 1 1 2 2. One 3 1 1 2 2, right? n equals to 3. 2 has a number of 2's, so answer equals to 0, n is equal to 3. Number of size, so s equals to 2. Then k minus n. Okay, what? Why is my webcam stuck? Hi guys. Hello. Why is my webcam stuck? Yo. Why is my webcam stuck? Can you see me? It's stuck. I don't know why. Oh, to see without. 'Cause you look so pretty when you tell me that you love me. I wish that I could lie, but my mind gets in the way. Wait, what is that? I know you think that I'm always way too self-aware. Oh, we could never be together, but we have to. Number of ones should be greater than or equal to number of twos and threes. Okay, there's a thing. Okay, what we can do is what we did with the brackets thing. So brackets, do you know that opening and closing brackets questions we were assigning +1 and -1. So here it is the same thing, right? That the number of ones. Just a minute. Okay, I'm not visible, so I'll show you. So in three parts, here the number of ones should be greater than or equal to number of twos and threes. Here the number of ones and twos should be greater than or equal to 3. So we'll assign +1 here and -1 here, and we'll go till finding a 0, that the prefix sum is 0. And after that uh, what we can do is what can we do? We need to find this, right? So let's say prefix of I, this is prefix of I, right, is 0 0 here, here and here. And now we need 1 plus 2 should also be greater than, should be positive. Let's say positive here, here and here, and we need this to also be positive. Prefix 2 of I should also be greater than equal to 0, right? So let's say this is green, and these are all the green where it is greater than equal to 0, but we only need it in the second part, right? Not from the beginning, only till this, from this second part we need that. Okay, so that is the thing. So we can use two different things, right? So prefix of r is equal to prefix of r minus prefix of l, right? Let's say we'll find till index I. So prefix of r minus prefix of I minus 1 is from I to r. So we'll do that. What can we do? What I mean to do is, this is a question, right? So we'll create prefix arrays of size n. Let's say this is prefix 1 and there's another prefix 2. There's a prefix 2. So we'll iterate through the loop, and okay, I need to erase this. If a at I is equal to 1, we need a sum. This is a sum, right? So int sum 1 equals to 0 and sum 2 equals to 0. So we start from 0. So if we find a 1, we'll do plus plus s1. We'll do plus plus s1 else minus minus s1. Similarly, if we find a 3, if we find a 3 plus plus s2 else minus minus s2. And for each of these we need prefix of 1 of I equals to s1 and prefix 2 at I equals to s2. Okay, that was it. So now we have the things. Now we need greater than equal to 0, right? So we'll include a for loop from int j equals 0 till j is less than n. Not j is till j is less than n minus 1. We'll do j plus plus. I'll tell you why. Okay, so this is it, and then in this we'll iterate through the I is equal to j minus 1 till I. Okay, for each we'll do just a j minus 1. Okay, int I equals to j minus 1. So for each second index we need to find a first index. So we need a minimum. J is the second index. Okay, J is second break and I is first break. So j minus 1. If p1, right, p1 of I is greater than equal to 0, if p1 of I is greater than equal to 0, this is a valid answer, but we need another, let's say minimum, right? We need the minimum thing. Int min equals to math dot min of min comma, okay, this is just integer dot max value, right? So here min equals to math dot min of min itself comma the index I, right? We have found the index I, not the index I, p2 at I think. Is it p2 of I? We need to find a thing where p1 is greater than equal to 0. Or p2, the minimum position of p2. Okay, there's just a small thing I'm not able to get. So P1 is for 1 and P2 is for the 3 thing, right? That means the left. Okay. So for the first part I have done the P1 thing, and for the second part I have done the P2 thing, right? No, if it is 3 then we need a minus minus 1. Minus minus is 2. Else plus plus is 2. I'll tell you. Okay, this is the thing. Total score. Where's my stylus? So this is the array. Just a minute. This is the array, let's say. And the first part, for the first part we do, if it is 1 then we'll do plus 1, if it is 2 or 3 we'll do minus 1. So for the first part we need the sum to be greater than equal to 0. Then again for the second part, if it is 1 or 2, second part, okay, if it is 1 or 2 it should be plus 1 and 3 should be minus 1, and again sum should be greater than equal to 0. So what happens is this just 2 comes here. Right. Should be greater than equal to 0. If it is 2 or 3 it comes here, but here 2 comes as negative. So the scoring becomes this. So the total score of this should be greater than equal to 0. Let's say let's say there was a prefix sum, right? So the left part was how much time is left again? Should I check? Where is the time left? I can't see it. Okay, there must be only 8, right? It is 10 now. It should be quick. So loop over the second cut. Okay, so the middle and right part should contain at least one element. So 1 to n minus 2, right? From 1 to n minus 2. And after that the first cut is first a previous cut. Let's say previous cut as the previous cut. Is it valid? If it is valid, then we should include that. If it is non-negative, right? We need to store the smallest math minimum of we need to include the smallest one. Because it is just greater than equal to, right? Just. The minimum of the first index. Okay, now the I is the first index, so it should be p2 of I. So minimum of p2 of I, and then it should be greater than p2 of j. So if okay, so that was it. If this min is less than equal to p2 okay, if this okay, wait, we need to set a boolean flag equals to false, right? So j equals to 1 to n minus 2 if p1 of j minus 1. If p1 of j minus 1 is greater than equal to, let's do it j minus 1, right? J minus 1 is greater than equal to 0, min equals to math min of p2 of this j minus 1. J minus 1. Okay, now we check if it is valid, whether is there a valid first cut. So if this p2 of j, right, it is true, then flag is true. Then flag equals to true and break. And if this is flag, let's say, then we need to print it. Yeah, that's this. So this should work. Yeah, this works. It is taking a lot of time, but why is it taking a lot of time? I don't know why, but it should work. So let's submit it. So next problem, the C1, right? So if it is a duplicate, we can, okay, let me check the status. Okay, ta 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 ra 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 ta ta ra ra ta 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 ra ra. Contest click. Ta ra 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 ta ta ra ra ta 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 ra ra ta. Okay, accepted. Nice. Okay, cool. I need to solve the third one also. Unstable elements. What is this? So if it is a duplicate, we just need the first. This is in sorted array, so we just need to first instance. Blocks of elements, right? So the first element, either we delete it or we add a duplicate to it. The coding phase is finished. Oh my god, I just solved 2 of these. Yeah, the time is over. I just barely solved this. Oh, what the hell? Okay, this language. Okay, I barely solved this, man. Okay, thank you guys. for watching. Love you, Shravani.